Hello guys, welcome you all to debugging doubts. So in the previous video, I have told how to use these functions and we have also seen how we have tracked line marks, right? So in this session, we will be seeing how we use the functions and make hand gesture control. So if you haven't watched my previous video, just click here the above link and watch my previous video. Then only you will get to understand it easily in a better way. So let us start. now. So first thing, let us see what we have done. So when I run this, you can see me and also you can see how my hands are tracked. If even if I move, it will still detect the points. Okay. I press escape for exiting and then what now I will do further is first thing I will define here labels. So what labels we are having. Okay. So label. So handness dot classification 0 dot labels. So it will detect whether it is a left hand or it is a right hand. So that's it. And then what I do is I will write height, comma, width, comma, image dot shape. So this will detect the height and width of the image. First we'll print what the H, W and C are. Okay. Print. So I'll write H, comma, W, comma, C. Okay. So now let us check what will be this doing. So see, you can see where the hands have been tracked, right? You can see this kind of values. So this is the width of the screen and height of the screen. We'll remove this one for ID, comma, LM in enumerate and this functions this okay print ID, comma, LM. Okay. So what this enumerate function does is it will take the hand landmarks. You can see for each of the hand we are running right two times we are running this for loop. So dot landmark. Okay, and from that landmark we will enumerate. That is, we'll find the IDs and also the landmarks and print it here. So you will get to know what when I will do this. So run this file and just wait for a while and see. Okay, I'll press escape and you can see the landmark. So what is this all values? So I shown that hand has many points, right? Like 0 to 20. So for each of the points, we are getting x-axis, y-axis and z-axis values. So that is what we are going to print here. So we'll use it for controlling further part. Okay. So instead of printing, we will write uh, cx comma cy two variables and int of lm dot x. So lm dot x is the landmark and the x-axis value. Okay. So multiplied with the uh, width of the screen. And then for cy, I'll write int same thing. Okay. lm dot y into height of the screen. So now we are getting random values from 0 to 1, right? So we'll be multiplying the screen width and getting the exact location. That's all we'll be doing. And then print cx, comma, cy. Now also I will print the ID. Okay. So these three values I'll be printing. So let us see. Clear and run. So you can see the values. So for 20, it is 428 dot this, and you can see all the values from 0 to 20. So it is completely repeating, right? So that's all we are printing each time. So this is x-axis and this is y-axis. So instead of printing, let us define a list called as lm list is equal to here, and then here I will just write this. Okay, lm list dot append. So each time I'll be appending all these values, that is id, cx and cy. So I'll be using list instead of tuple. And also I will just remove this here and I will write it after doing all sorts of functions simply. Okay, I have saved and it automatically got uh, formatted. So don't worry, nothing is changed here. It is as it is. So this was our next checkpoint. Now we need to make such kind of function where we will be detecting fingers, whether it is closed or whether it is open and all such sorts of things. So let us do that. So let us start from here. So after drawing fingers, I'll write one more function called as finger, and I will uh, take values from count fingers lm list. I'll pass this list of values that is we have appended, right? So each of the id x-axis and y-axis. Then label. So label was what we defined it here. Label is whether it is left or it is right. We'll write it here, left or right. Okay. And then you can see this function is not yet defined. So we need to define it here. So here before the try block, I'll defining def count fingers, and then for currently I'll write pass. Okay. So let it define later. So what this function returns? This function returns how many number of fingers are opened. Now let us see where are the finger was here. So now we'll check if finger opened is greater than or equal to 4. Then we need to write state equals open. Okay. Just give everything here. Okay. Then elif. So elif means else if finger. Wait a moment. Finger is less than or equal to 1. Then what I will do is state is closed. Else, if finger is between 1 to here, we'll write it as partially open. Or you can say mid, better, or partial. Okay. So we are defined how the finger is opened or not for each of the hand. You can see in this for loop, we are iterating in each of the hand. So we'll be defining finger is 5, then open. Finger is 0, then it is closed. Means all the fingers are closed, then your hand is closed. Else partially open. That is 3, 4 fingers are open. Now what we need to do is we need to go here. Okay. Here we can define two values. That is left state is none and right state is none. Okay. Just wait a minute. Yeah, right. Then come below. And here, what we'll do is we'll check which hand is open. If label equal to left. So what we'll do, if it is left, we'll write left state is equal to state. Else, we'll say that right state is equal to state. So state is open or close is for one hand. Okay. Now understand. State is open or close from one hand. And then what we do is we'll check whether it is a left hand or right hand. In this for loop, we'll be tracing one's left hand, one's right hand. So we'll be checking if it is left hand, then assign the state to the left state. And if it is right hand, assign the state to the right state. That's all we are defined. So now we'll go out of this if block. Okay, so multi-hand detection is done. So now we'll go out of this if block. So 1, 2. So still we are out. No, okay, we are inside the for loop only. Yeah. Now we are here outside the if block. Okay. Now what we'll check is we'll write the actions. So what action will be performing? action equals to stop, and then required keys is equal to empty set. I mean empty list. Okay. So why we are done? We need to define whether the car is stop, whether the car is moving or forward, left, right. All this value will be taken here. And required keys is what buttons we need to press to make sure the action is done. Understood? Now let us define the if else block. So if left state is equal to open and right state is open means left hand and right hand both are open, then what I will do, action move forward, and the required key is W, so W will be pressed. But what I will write, I need to define some kind of function that I will see later. Then what we'll do, else if it is left hand is closed and right hand is closed, then we'll go backward. Else if left hand is open, right hand is closed. Okay, try to imagine. Then what we do, we'll turn left. I mean, we should turn right according to what I've done. So this I'll make it as right and this as left. Okay. So if you are going right, then you'll press D, and if you're going left, you'll press A. So this will be doing right. So if you close left hand, you'll go to left. That's what I have done. And later on, we'll write a leaf means left hand is partial and right hand is partial. Then no need of doing anything. I will just say the action to be stop, and required keys is nothing. So this function here you can understand it clearly how we are written. Okay. Now we will be defining what kind of actions will be done. We'll print in the image only. So what is cvt.putText does? So it will put text in the image. So we are given what image we will be printing, right? Same image. Then action will be printing. So this is text what we will be going to print. And then this is the location. So color, font, then everything sorts of will be passing as parameter. And now we need to check how it works. So before that, I made a mistake. I did not give space. Now let us start disclosing. Not supported before is type. Okay, you can see I have given count fingers, but the function is not defined yet. So I will currently tell it return one. Okay, so let us check. So now I will run the file and let's see. Yeah, you can see move backward. This is stop because partial. If you can see in the function, we have given so left state and right state. So whenever the hand is detected, so that's what we I have told here, right? If hand is not detected, then directly it will continue. It will not execute the below code. That's why I told in the beginning. Now you can see whenever I lift my one hand, so this will become false and it will run the code and it will check here it is open or not. So that fingers will be returning one, right? Just now I defined return one. So so if the finger is less than one, it will say closed. So we'll give closed for left hand and also for right hand. And then both of the hand are closed and move backward. That's why when I lift two hand, it says move backward. So now we need to define this function that is count fingers to make it ensure properly. Let's do that. So already I have a code written for that. So I will not waste the time. So I'll just print here. Okay. So you can see fingers. Okay, so this is fingers and you need to define. So we'll define the tip IDs first and then fingers. So what is fingers do? let's define fingers first inside. Okay, no need of any kind of conflicts. Now, what this tip ID is? So, as I showed the image, you can see. So, tip ID is a collection where I defined 4, 8, 12, 16, and 20. So, these are all tip ID of each finger. Then, what we do is we'll take fingers for I in the range 1 to 5. So, we'll go from 1, 2, 3, 4, and each of the finger 8, 12, 16, 20, we'll check. Fingers dot append 1. If LM list tip IDs of I, so tip ID of I is the I index of, I mean, say, if it is 1, the first finger's tip ID. So first finger's tip ID, LM list will have already. So LM list is collection of all that values, right? I have shown in the earlier. So it will have finger ID, then x-axis and then y-axis. So that will take row has the fingers ID and 2 is the x or y. So here 1 is x-axis and 2 is y-axis. Okay. So in the finger, this LM list. So we'll take that ID. We'll check whether 4, I mean this 1, 2, 3, 4. We'll check whether 8. So tip ID of this is 8, right? So it will give 8 and 2. So LM list of 8 has axis and y-axis value. So 2 is y-axis value. So here you can see tip ID minus 2. So 8 minus 2 is 6. So we'll check 8 is less than 6 or not. First of all, there is a very important concept that in maths, what we will be doing is we kept a origin and x-axis was increasing when we go towards right and y-axis increases when we go towards upside. But in OpenCV, this is reverse. So x-axis will be same. That is, while moving rightwards, it will be increasing. But y-axis, while moving downwards, it is increasing and not decreasing. So this is why we have shown that hand finger, right? So if 8 is less than 6, means 8 is above and 6 is below. Then what we'll do? We'll print 1. Means this finger is open. Index finger is open. So that is why we are given 8 is index finger. Then what we do, we'll check whether it is less than, then only append 1, else 0. But there is one problem for thumb finger, right? So thumb finger, we'll check whether it is 4 is less than 3. So we'll be moving towards this side. And 4 is greater than 3, we'll move from this side. So that's why we'll write different function for thumb. So I will take that code and paste it here. So this is hand label to write it as label, right? Label only. Okay. So if so, that's why we are taken label whether to data whether it is right hand or left hand because both the hands it will be reverse, right? So if right hand, then what we'll do? We'll check whether the thumbs this 4 and 3. That's why we are taken tip ID and tip ID minus 1, not minus 2. So in this we are taking 8 and 6, 12 and 10, 16, 14. But in thumb we are taking 4 and 3. That's why. So we'll check whether it is greater. So if it is right, then we'll check greater. And if it is greater, then we'll write 1, L 0. So this thing you need to imagine a little bit. Okay. If it is left, we'll just change it reversely. So then what we do, we'll give fingers dot count. So what does fingers count do? So we'll be having arrays like this one. So 0, 1, 2, 0, 1, mean 1 comma 1. So what it indicates? So all these three fingers are up. So it fingers dot count will count only 1, 1 and 1. So that is 3. So it will return 3. So that's how it will return the finger count. So to show that thing also, I will just write print fingers list. Okay, fingers list. So now let us run. So main.py and let's see and see you can see the values, right? So if I close this, it will take values. So action is also stop. Now if I put both the hands, you can see move forward. And if I close one, turn right. And if I close this one, turn left. And if I close both, move backward. And that's how it's working. And if I remove the hands, it will be stop. And this is also stop. So this was the code. And now I will remove these print functions we don't require. Just I showed how it works. So that's it. So that was a little long video for today, but we have left with only the small part, that is connecting all the stuffs with the real world game. So that thing I'll do in the coming session, and I hope you all guys will like it. And thank you all guys for supporting. Keep supporting for more videos. Thank you all.